Welcome back, everybody. In this fourth part of our videos on multiplication of fractions, we're going to be focusing on examples, especially ones that require simplification, and then also areas of shapes. So let's have a look first at this problem, number 6. We have negative 4/19 times 21/8. And so let me first just recopy the problem slightly, and then we'll take a look and see what simplification can happen. So the negative 4 and the 8 both have a common factor of 4, which we'll divide out. So negative 4 divided by 4 is negative 1, and then 8 divided by 4 is 2. And then taking a look, it doesn't appear that there is any other simplification that can be performed. So let's just multiply across. We have negative 1 times 21, which is negative 21. And then 19 times 2, which is 38. Okay, and then one thing, yet another thing worth mentioning is that we saw in this last step that after dividing out that factor of 4, that there was no other simplification that needed to be done. So once you've determined that all the simplification, like in this step, is done, you don't need to look to see if this needs simplifying, because if you've done it all back here, then there's nothing else to be done here. So I know negative 21/38 is simplified because we did all of it earlier. Okay, so the negative 21/38 is finished. All right, let's have a look at number 8 next. Number 8 looks relatively small. It looks like there's only a common factor of 2 in this one, so we'll divide that out. 6 divided by 2 is 3, and 2 divided by 2 is 1. So then multiplying across, we'll have negative 27 and then sevenths. All right, and then that's it. Okay, I was going to pass over number 7, but it looks actually kind of interesting to me. So let me go ahead and do number 7. So for this one, we have 20 over 11, and then negative 17 over 22. So now taking a look for things that may simplify, the 20 and 22 have a common factor of 2, which may be divided out. 20 divided by 2 is 10, and 22 divided by 2 is 11. And so we've divided out that common factor of 2. And the reason I wanted to go back and actually do this one is you can see both of the 11s down here on the bottom. That's nice and everything, but there's nothing you can do about like simplifying it out or anything, because of course they're both on the denominator, right? And as you know, with the fundamental property of fractions, you would need to divide the top and bottom of the fraction by something. All right, so we'll have negative 170, and then that's divided by 121. Okay. All right, what else have we got? All right, let's do number 10, and then if we feel like it, we'll go back and do number 9. Okay, so for number 10, I can see that with the negative 3 and the 18, there's a common factor of 3, which can be divided out. Negative 3 divided by 3 is negative 1. And then 18 divided by 3 is 6. And then it doesn't look like there's anything else that can be done. So multiplying across, negative 17 times negative 1 is positive 17. And then down below, 6 times 4 is 24. Okay, so that one didn't take a lot of steps, so I think I'll go ahead and do this number 9 as well. So let's see how that looks. Maybe that will have more for us to do, and in fact it will, so that's good. Okay, so let me recopy that. So we'll have 21 over 8 times negative 14 over 15. So now the 21 and 15 have a common factor of 3, which we can divide out. 21 divided by 3 will be 7. 15 divided by 3 will be 5. Okay, and then just to keep it clear-ish, I'm going to do more simplifying in the next step. So let me just recopy. So we'll have 7/8 times negative 14 fifths. Okay, and then 8 and 14 have a common factor of 2, which can be divided out. 8 divided by 2 is 4, and negative 14 divided by 2 is negative 7. Really helps to know your multiplication tables to do all this, doesn't it? All right, so now 7 times negative 7 will be negative 49, and then 4 times 5 will be 20. Okay, so these are kind of fun and relaxing, or at least I hope you think so too. Okay, so let's see about some more examples. All right, so once again, we're going to try some even problems and maybe some odd problems too, if we feel like it. So I'm going to do 12 and 14 next. So take a moment, pause the video, try this yourself, and then restart the video and see how you did. Make sure that you're simplifying as much as you possibly can. Okay, so let's start in with number 12 first. So what can be done? Anything. Well, 5 and 20, no, I can't do anything with that because they're both on top. I need something on the top and something on the bottom. The negative 20 and 2 have a common factor of 2, which can be divided out. That will leave a 1 in the denominator and a negative 10 in the numerator. And it looks like that's all that can be done. So negative across tops, we have negative 5 times negative 10, which is positive 50. Down below, 1 times 19 is 19. Okay, a lot of this is really just about following the directions. Okay, let's see. For number 14, the 12 and the 9 have a common factor of 3. So let's divide that out. Negative 12 divided by 3 is negative 4. 9 divided by 3 is 3. And that's all that can be done. Multiplying across, we have negative 4 times 5 is negative 20. 7 times 3 is 21 down below. Okay. Number 13, I'm going to skip over that one in the interest of time. But taking a look at it, you should recognize that the 8 and 6 have a common factor of 2. Okay, let's try number 15 next. This one, there's 2 simplifications that can be done. The 2 and the 8 will have a factor of 2. And then negative 9 and 15 will have a factor of 3. So we'll go ahead and do that one. So the 2 and the 8 have that common factor of 2, which we'll remove, dividing the top and bottom by 2. And then this will leave us with 1/15 times negative 9/4. Okay, and then of course the 9 and 15 have a common factor of 3, which we'll want to remove. So 15 divided by 3 is 5. Negative 9 divided by 3 is negative 3. That's a bad looking 3. Let's fix that. Okay. All done with the common factors. Multiplying across, 1 times negative 3 is negative 3. 5 times 4 is 20. And once again, I don't have to check and see if that thing simplifies because I know I did everything I could on the preceding step. All right, 16, this will be our last one. So here, the 2 and the 8 have a common factor of 2, which can be removed. Okay, and then that's it. So let's multiply across. We'll have 1 times negative 21, which is negative 21, and then 11 times 4, which is 44. And again, that's guaranteed simplified if we've simplified as much as we can in the preceding step. Okay, so in our next couple examples, we're going to work on some areas. So let's do that. So I wanted to remember with you the area for a triangle first. And on these, the side lengths for the triangles are just whole numbers. So that makes it relatively simple. Remember that the area for a triangle is 1/2 times the base side of the triangle times the height. Okay. And so for this first one, number 66, we'll have 1/2 times the base, which is 10, times the height, which is 15. Multiplying 1/2 of 10, I guess that was a fraction after all, 1/2 of 10. Here, we can simplify out a factor of 2. So 2 divided by 2 is 1, 10 divided by 2 is 5. Okay, so this will give us 1/1, not a lot to do there, times 5/1 times 15. That's the same as 5 times 15, which is 75. And then we would need units on there. And so since our lengths are measured in feet, it will be square feet. 75 square feet. Okay, so now number 67. It's going to be 1/2, the base, which is 5, times the height, which is 4. Now on this, remember that multiplication is commutative, right? So it doesn't matter what order you multiply in. So we can, if you want, remake this as 1/2 4 times 5. Maybe that's easier to think about. 1/2 of 4 is 2. 2 times 5 is 10. And that'll be in square centimeters. I did this one slightly differently than the last one, just for variety's sake. In number 66, I showed a little fraction simplification. In number 67, I didn't show it. I just figured that you would know that 1/2 of 4 is 2. Okay? And we remembered about the fact that multiplication is commutative. All right, so now this will be number 68. So 1/2. The base here is the 14. So that's 14. And then the height is 6. All right, so height normally, pause for a second. Height normally you think of as up and down, right? That makes sense. How tall are you? What is your height? And here I'm saying, okay, the height is going down and to your right. How can that be the height? That's one of the situations where we have an everyday word meaning something specific in math. The height of this triangle is basically the distance at a right angle from whatever side we're considering to be the base. If we took this whole picture and rotated it around so that the base was sitting on the bottom instead of kind of, up and to the right like it's shown in the first place, we'd have a base of 14 and a height of 6 looking like that. And that looks more like a height, right? So remember that the area of the triangle is not going to be dependent on how much it's turned. So it's all okay. Okay, so 1/2 times 14 times 6 for this. And so then we can simplify. 1/2 and 14 have a common factor of 2, which we'll divide out. This will leave us 1/1 times 7/1 times 6. And that's going to be 7 times 6, or 42. And our units there are inches, so it will be square inches for area. All right. Finally, 1 or 2 with a fraction in it. This triangle has a base of 16/45, and then a height of 15/32, but that's okay. So we'll have 1/2 times the base, which is 16/45, times the height, which is 15/32. Okay, so now we get a bunch of simplification we can do, hopefully. So I see the 1/2 and the 16 have a common factor of 2. So let me take that out. 16 divided by 2 is 8. 2 divided by 2 is 1. Okay, let's see what else we can do. 45 and 15 have a common factor of 3 and 5. So 15. 15 divided by 15 is 1. And 45 divided by 15 is 3. Okay, there's more that can be done, but I'm going to rewrite here so it doesn't have so much scratch outs. We'll have 1/1 times 8/3 times 1/32. Okay, so now there's a lot of 1s, which is good, but I can see that 8 and 32 have a common factor of 8, so we'll take care of that. 8 divided by 8 is 1, 32 divided by 8 is 4. Okay, so now we are okay. Multiplying across the top, we have 1 times 1 times 1, which is 1. And down below, 1 times 3 times 4, which is 12. So we'll just have 1/12 for the area of that triangle. Okay, next step, we have a little right triangle. Why don't you pause the video and take a moment, try to find the area of this triangle, and then restart the video and see how you did. Okay, so we have 1/2. The base is 9/16, and then the height is 3/10. Okay, so let's see about any kind of simplification that can be done here. So is there anything that could be done here? Well, the 2 doesn't have any common factors with 9 and 3. 16 and 10 in the denominator don't have any common factors with anything in the numerator. And so there's no simplification that could be done here. So sometimes that happens and it's okay. So we'll multiply across the top. 1 times 9 is 9, times 3 is 27. And then down below, 2 times 16 is 32, times 10 is 320. Okay, it just so happens that there was no simplification that could be done in this example. All right, so we just have a couple more examples left to do, and then we'll be all finished. For the next one, we want to find the area of this parallelogram, which is shown here. So remember that the formula for the area of a parallelogram was the same as the area of a rectangle. So it's just the base times the height. Is the base times the height. Okay, so this will be the 3/8, or base, I guess, is the 14/15, times the height, which is 3/8. All right. Of course, multiplying the other way around would give the same answer. I just wanted to be consistent with my labeling. Usually the base is the across and the height is the up and down. Okay, so 14/15 and 3/8. Let's check for common factors. I can see the 14 and the 8 have a common factor of 2, which we can remove. 14 divided by 2 is 7, and 8 divided by 2 is 4. Okay, so we'll give us 7/15 times 3/4. In here, the 3 and the 15 have a common factor of 3, which we can remove. 3 divided by 3 is 1, 15 divided by 3 is 5. And now we're okay. Multiplying across, 7 times 1 is 7. Down below, 5 times 4 is 20. Okay. So now we want to move on to some text examples, that is written problems, story problems. So let's try that next. So here it says it takes 5/8 of a yard of ribbon to wrap a package. We want to know how much ribbon will be needed to wrap 6 packages. We're to give a simplified fraction, improper fraction as an answer. So let's think about that for a second. It's 5/8 of a yard of ribbon for 6 packages. So one thing that you can do is simplify the problem just to get a plan by taking out the fractions and making it whole numbers. Let's say that instead of 5/8 of a yard, let's say that it took 2 yards of ribbon for the 6 packages. Then it would be 2 for the first one, 2 for the second, 2 for the third, 6 times, right? So that sounds like 2 times 6. We're doing something over and over again, and that's one of the meanings of multiplication is repeated addition. So where if it was 2 yards, we would say 2 times 6 or 12 yards. That's our plan. Okay, multiplication, repeated addition for doing something basically over and over again. Of course, in our given problem, it's really 5/8, but our plan for finishing the problem is going to be the same. We're going to have 5/8 of a yard for the 6 packages. Okay, so we're basically adding up 5/8 over and over again. And so we're doing it 6 times. That's 6 times 5/8. All right, so 6 times 5/8. Remember, 6 can be viewed as 6 over 1, if that helps you. And so writing it this way, we'll have 6 times 5/8. The 6 and the 5/8, 6 and 8 have a common factor of 2, which we'll remove. 6 divided by 2 is 3, and 8 divided by 2 is 4. Multiplying across, 3 times 5 is 15, and 1 times 4 is 4. So 15/4 will be our simplified improper fraction. Okay, next question. Sal's yard is 7/8 of an acre. On Saturday, he mowed 3/4 of it. We want to know how many acres did Sal mow. So this is kind of taking a part of a part. Sal's whole yard is 7/8 of an acre. How much or what piece of it did he mow? He mowed 3/4 of it. Multiplication by a fraction is one way we have taking a part. Again, let's pretend that he had 8 acres. If he mowed 3/4 of that, okay, 8 acres. Sorry, I was supposed to be done drawing pictures. All right, let's say that he had 8 acres. If he mowed 3/4 of that, that's 6 acres, right? So 3/4 times 8 is 6 acres. All right, so taking apart. Multiplication by fraction is used for taking a part of something. So we'll take 3/4 of his 7/8 of an acre. Okay, once you've got the plan, to finish is not so bad. Any simplification? Doesn't look like it, right? Okay, nothing to do with the 4 and the 8, and so we'll just multiply across. 3 times 7 is 21, and 4 times 8 is 32. So it's 21/32 of an acre. All right, last example, and then we're all done. Okay, Anna buys 6 sheets of 3/4 inch thick plywood. She lays it flat in her pickup truck or a truck. We want to know how tall is the stack of plywood. Okay, so again, we have 3/4 on top of 3/4 on top of 3/4 over and over again. And so that sounds like multiplication by a fraction. Okay, we have 6 times 3/4. And so again, 6 can be viewed as 6 over 1. This time we do get a little bit of simplification. And so 6 and 4 have a common factor of 2. 4 divided by 2 is 2. And 6 divided by 2 is 3. Let's multiply across. 3 times 3 is 9. And 1 times 2 is 2. Okay, so it's going to be 9/2. And that will be in inches. Okay, so that takes us to the end of our work on multiplication and the end of this video. So let me know if you have any questions, and then have a great day.